Okay, so we're given a matrix A, which is a 3 by 3. There's 3 rows, 3 columns. Then we're asked to verify that if you multiply by the identity matrix I3, oops, sorry about that. And I3 is the identity matrix, looks like this over here. It's a 3 by 3, where all entries are 0, except the diagonal is filled with ones. All right. So what do they want me to do? They want to verify that if I took the matrix A and multiplied it by that matrix I3, that I get the same thing as if I took I3 and multiplied it by A. Let's take a look at this. Let's write it down. That's what they want me to verify. And this is going to be 1, 0, 0. Yeah, it might seem like a lot of busy work to you, but one is you're going to improve your skill set in multiplication. And you're going to see something interesting about identity matrices. Gee, I hope the copy right. Let's take a look. What I would recommend you do, at least initially, know what you're doing. All right. So that's row 1 times column 1 would give you the entry row 1, column 1. Now, I'm not going to put a bunch of circles down, but I want to emphasize that if this is 3 by 3 and this is 3 by 3, the internal dimensions must match, and the outcome of this will be a 3 by 3. This 2 is a 3 by 3, and this is a 3 by 3. These internal numbers match. This is going to be the outcome of it, which is 3 by 3. So at least I know both are 3 by 3 matrices. So let's do this first. I'm going to do row 1, column 1. I'm going to do left side, and that would give you -2. All right. Now we're going to do row 1 times column 2. Well, no, I'm not going to circle. That's just 3. Now I'm going to do row 1 times column 3, and that would just be the number -5. Fairly simple. All right. Now we're going to do row 2 times column 1, and that would be 4. Row 2 times column 2, that would be -1. Row 2 times column 3, and that would be 1. Row 3 times column 1, -7. Row 3 times column 2 is going to be 6. And row 3 times column 3 is going to be 0. All right, so we did that. Now what are we going to do? We're going to do the other side. We're doing this, row 1 times column 1. All right, now what's that going to give me? -2, that's row 1 times column 1. Row 1 times column 2 is 3. Row 1 times column 3 is -5. Now we're doing row 2. Row 2 times column 1 is 4. Row 2 times column 2 is -1. Row 2 times column 3 is going to be 1. Now we're going to do row 3 times column 1, -7. Row 3 times column 2, 6. Row 3 times column 3, 0. They want us to verify that it actually gave us the matrix A back. Look at it. Is that the matrix A? Yes. You may want to look at by entry, -2, 3, 3, -5, 4, 4, -1, 1, -7, 6, and 0. And certainly verify it up here too. -2, 3, -5, 4, -1, 1, -7, 6, 0. So what have you learned about these identity matrices? That if you multiply A by its identity, and A square matrix, it's commutative. All right, you can do it A times I or I times A. No, the outcome's not going to be different. All right, so that was number 1. Now we're going to go to number 2. And they say, what's the dimensions of the product A times B? Well, I'm going to write this down. A times B. With the understanding that A is a 3x2 and B is a 2x5. Well, the internal dimensions must match. What's the outcome going to be? The outcome is going to be a 3x5 matrix. Okay, we're done with that. Let's go to the next one. Number 3 says, find the product. All right, let me just point out what we're going to do over here before we even find the product. I'm going to look at the dimensions of each of these. The first one is 2x3. That's 2 rows, 3 columns. The next one's 3x3. These must match. What's the outcome going to be? It's going to be a 2x3. Again, we're practicing our multiplication. That's all we're doing. I'm going to circle row 1 times column 1. We'll check it in the answer key later. What's that going to give me? Well, looking at it, 3 times 0, 0, minus 1, 0, minus 1. Okay. Now we're going to do row 1 times column 2. A little more complicated. And you might want to write this on the side, but I think I can do it. That's going to be 3 minus 5 plus 0. Well, 3 minus 5 is minus 2. Now let's do the next one. Row 1 times column 3. What's that going to be? 6 minus 1 plus 0. That's going to be 5. All right, let's do the next one. Now we're on row 2, column 1. Well, I get 0, 2, 0, which is 2. Now I'm going to do row 2 times column 2. That's going to give me 4 plus 10 plus 5, which would be 19. We'll check with the key later. Now we're going to do row 2 times column 3. That would be 8 plus 2 minus 5. That's going to be 5. Let's look at the key. Let's see if we got the right answer. Okay, let's keep going. And this one says show that B is the inverse of A. And then it says to show that B is the inverse of A, all we need to show is that AB equals I. I'll write this down for you. And while we're at it, we might as well show that BA is, that's a B, BA is also I. Let's go through it one step at a time. So I'm looking at it, and certainly I'm going to do the multiplication for you, but I'll write it down for you. I'll put AB down first, and that's going to be 3 minus 5 minus 1, 2. And what's B? 2, 5, 1, 3. So I'm doing this first. Let's do it. What do you get? Well, I'm going to again emphasize what we're doing. It's a 2 by 2 times a 2 by 2. The result will be a 2 by 2. The result will be 2 by 2. What do you get over here? Well, you get 6 minus 5 is 1. Then what do you get? 15 minus 15, that's 0. Then what do you get? Minus 2 plus 2 is 0. Then what do you get? Minus 5 plus 6, which is 1. We just verified. What's this thing going to be? I2. Let's do B. What's B? 2, 5 and 1, 3 times A, which is 3 minus 5 minus 1, 2. All right, let's see if we can do that. Both are 2 by 2. I know my outcome is going to be a 2 by 2. So what do you get there? You get 6 minus 5, that's 1. Then you get minus 10 plus 10, that's 0. Then you're going to get 3 minus 3 is 0. Then you can get minus 5 plus 6, which is 1. We did it again. We just verified what they said is going to verify, that this is in fact an identity matrix I2. All right, let's keep going. And the same type of question. They want me to do this one for a 3 by 3 now. I guess what they want me to do is really practice. I noticed something strange here. I want to point it out to you. And this is, I can't say totally strange, but in effect, it's actually an act of kindness. And what you could do instead, say, well, why don't you write it the way a computer would have given it to me? And what I mean by that, you could write this thing as this over here. I don't recommend it, by the way, but you could. That's what computers do. Like I said, I don't want to do that. What I want to do is, I want to do the multiplication A times B. As I do that, I'm going to write A down for it. Not that you have to, but it's 1, 0, minus 1. And you get minus 1, 2, 0, 1, 5, 0. And I notice that 1/7 kind of bothers me. I know it's a scalar, so I'm just going to put it in front of the problem now. What do you get over there? 0, minus 5, 2, 0, 1, 1, minus 7, minus 5, and 2. All right. Now, what do I know about this thing over here? Well, I know I got 1/7 here. That's my problem. But I know the first matrix is 3 by 3, the second matrix 3 by 3. I know my outcome is going to be 3 by 3. Let's go through it one step at a time. And again, I like to make circles. If they're helpful, good. If they're not helpful, don't do the circle. What do you get there? 0, 0, 7. I'll write that down for you. What's the next one going to be? Let's see, minus 5, 0, and 5. That would be 0. What's the next entry going to be? 2, 0, minus 2. That's 0. Let's do the next one. We get 0, 0, 0. All right, next one. Well, 5. Let's see, 5, 2, that's 7, and 0, that's 7. Next one, minus 2, 2, and 0. That's 0. Next row, 0, 0, 0. Next one, minus 5, 5, and 0. That's 0. 2, 5, and 0. That's 7. Now multiply by the scalar 1/7. What do you get? 1, 0, 0, 0, 1, 0, 0, 0, 1, which is what? It's I3. We verified what they asked to verify. Now let's do the other one now. And what's that going to be? Matrix B times matrix A. And again, they want us to practice. Now, I realize some students say, oh, I can do this on a computer. So can I, but that's not the point. The point is, can you do simple things by hand? And if you can, then we'll go to the computer. Well, let's take a look, see what we get. All right, 1/7. And now I'm going to do this. They're both 3 by 3, by the way. And what do you get there? You get 0, then you get 5 and a 2, and that's a 7. And then what do you get? 0, let's see, minus 10 and 10. Oh, that's 0 again. Then what do you get? You get 0, 0, 0. That was pretty simple. Next one, 0, minus 1 and 1, 0. Next one, 0, 2, and 5. That's a 7. Next one, 0, 0, 0. Next one, oh boy, minus 7, plus 5, plus 2. That's 0. Next one, 0. Let's see, minus 10 and plus 10, that's 0. Next one, 7, 0, 0. Multiply it out, what do you get? 1, 0, 0. I'm doing a scalar multiplication now. 0, 1, 0, 0, 0, 1, which again is what it's supposed to show that it's actually I3. All right, so let's go back, make sure we've done that. That was number, I guess that was number 5, right? We'll go to the next page and see what they offer for me to do there. All right, the next one says use matrix multiplication and inverses. Well, I'm going to write that down. Now, by the way, in 50, they say inverses will be given in class. Well, I'll give it to you then, okay? I'm going to show you how I'm going to get it though. But the bottom line is, I want to write this down for you. All right, so this is, they want me to use matrix multiplication. So I'm going to write this down for you. So the matrix multiplication is going to be this. 2, 3, 2. That's the column of x's, 2, 3, 2. The column of y is going to be 3, 3, 4. The column of z's would be 1, 1, 1. Matrix multiplication. The variable matrix is x, y, z. And the constant matrix is -1, 1, -2. Now, what they said to do is, they said use matrix multiplication and inverses. Well, I'm going to write this down now. X, Y, Z. I'm multiplying both sides by the coefficient that would be the inverse, and I'll circle this for you, this guy over here. So I'm multiplying by the inverse of the coefficient matrix, both sides. What would I get? I basically get I3 on the left side, and I3 times XYZ matrix would just be XYZ. And what do you get on the right side? More complicated. It'll take more effort to do it. What's it going to be? 2, 3, 1, 3, 3, 1, 2, 4, 1. And I'm going to write down an inverse symbol there. Now, I don't know the inverse yet, but remember what it said. I'll give it to you. All right. So I'm going to scoot this over, and I'm going to switch to a different screen. I'm going to go through it with you. All right. So someone says, can we do them by hand? Of course we could, but I'm going to give it to you. Why would I do it by hand if I'm going to give something to you? All right. So give me a second. I'm going to do another share. And give me a minute to do that, okay? And I got to open up something here. Okay, give it a second to load. And I'm going to use Sage. And what I'm going to do, I'm going to say A is a matrix. Now, I'm hoping you have the notes in front of you. And what I'm going to do is enter the matrix now. And what's the row going to be? 2, 3, 1. What's nice about the notes, they have an answer key for you, and we can look at the answer key. So if I make a mistake, certainly I'll know I made a mistake just by looking at my answer key. Now, some people, when they make a mistake, they don't think it matters. It does matter, and we need to fess up to our mistakes, myself included. So I'm going to see if there's an error. No error, but I don't know if I did the right thing. Let me display A. We'll say 2, 3, 1, 3, 3, 1, 2, 4, 1. All right. Now, what I want to do, I want to take this inverse, and it's pretty easy to do on a computer. I just do A inverse. Now, I say it's easy, but maybe the computer says, oh, it's not invertible, whatever. I don't know. Okay. So it gave it to me. I'm going to write it down for you now, and I'll go back to my whiteboard in a second, but I have to copy it first. And you should also be in the mode where you copy things down. And hopefully you're able to do that. I know some students struggle with actually copying from the screen. And sometimes just there's a lot of distractions in their lives, and they have a hard time because there's too many things going on. All right, so I'm going to go back to another share. I'm going to stop this share. And I'm going back to my whiteboard. Okay, back in the whiteboard. So what did you just do? Well, I just opened up Sage and I found the inverse and I copied it down. Now I want to do the multiplication. And again, just to get you started, I want to point out, and again, I want to emphasize to you that the first matrix here is a 3 by 3. The second one's a 3 by 1. The outcome is going to be 3 by 1. So I know that much. Now, what do you get there? Well, you get 1 plus 1. That's 2. That's pretty simple. What do you get for the next one? 1 plus minus 2 would be minus 1. Now, someone says, what happens if you make a mistake? I'll know I made a mistake, by the way, when I check my work. Now, what's the next one going to be? You get, minus 6, minus 2, right? Maybe I should write that down for you. Minus 6, minus 2, plus 6. What would that give me? Well, I'm looking at it. It's pretty simple arithmetic. It's just minus 2. Now, what does that mean? It means x is 2, y is minus 1, and z is minus 2. Now, by the way, I don't know if that's right. Someone says, well, how could you check it? I could check it just by looking at the original. I'm going to pull this over here and blow it up, and I want to see if it's true. All right, I make mistakes all the time, by the way. Thank God for easy numbers, though. And I'm going to put the x's down first. What's the x? It's 2. So what's column going to be? Whoops, sorry about that. It would be, let's see, if x is 2, that would be 4, 6, and 4. Now, if y is minus 1, what would it get? Minus 3, minus 3, minus 4. And if z is minus 2, I would just get minus 2, minus 2, minus 2. All I'm doing is looking at this and seeing if it's true. We'll look at the key later. Is this minus 1? Is that 1? Is that minus 2? Well, let's see if it is. What's the first thing going to be? Well, 4 minus 3 is 1, and 1 minus 2 is minus 1. Worked out beautifully. Let's look at the second row. 6 minus 3 is 3, and 3 minus 2 is 1. That worked beautifully. What's next row going to be? 4 minus 4 is 0, and 0 minus 2 is minus 2. Right? Let's go back, look at the answer key, and see how we did. And what do they say in the answer key? X is 2, y is minus 1, and z is minus 2. Worked out pretty nicely. All right. So 51 says, using matrix multiplication and inverses, do this problem. All right. And what does it say? Inverses will be given. Okay. I'll give you the inverse. So I'm going to write down the matrix. And as I do that, let me just write it down for you. It's going to be 5, 2, 1, 4, minus 1, 4, minus 3. Whoops, that doesn't look like a 3, does it? 0 and 7. X, Y, Z equals 8, 2 minus 6. Write that down for you. Well, I'm going to multiply both sides, left multiplication, by the way, by the inverse of the coefficient matrix. And what would I get? Something pretty simple, actually. I get this. What's not simple, though, is finding the inverse, and I know it's difficult. What am I going to do? I'm going to switch screens now again. And someone says, do you get better at doing things by trying? And you do. And I always say you get slower if you don't try. All right. So I'm going to do this over here, and I'm just going to do A again. A is a matrix. Oops, I spelled matrix wrong, right? And I'm going to put the first row in. And someone says, what's the first row? I have to read it. It's 5, 4 minus 3. Yes, I'm looking at my notes to do that, not memorizing. And nor should you. That's why we have pen and paper. 2 minus 1, 0. Remember, if I make a mistake, the machine will not blow up. And the last row is 1, 4, 7. Okay, I don't think I made a mistake, but who knows? Maybe I typed the wrong number. Let's take a look. 5, 4 minus 3. I did that at good. 2 minus 1, 0. I did that good. And 1, 4, 7. And now what I want to do is do the inverse. And, maybe it's going to be really easy. I don't know. The machine doesn't, complain. Oh, look at that. That's terrible looking matrix. So I'm going to write down, I'm going to copy it down, by the way, but I just don't like the way it's written. And I'll write down what I'm seeing, but I'm going to write it differently. But I'm going to write down my notes. I'll come back to it later. So the first entry is 7 over 118. The next one's 20 over 59. And the next one's going to be 3 over 118. And the next one's 7 over 59. And the next one's minus 19 over 59. And 3 over 59. Again, I'm just copying, and you should too. I mean, you should learn to copy. Not that it's a great skill anymore, but you need to learn. And that's a lot of copying, isn't it? I'm going to go back to my notes. Just give it a moment. What I noticed is I don't like the fraction. So I'm going to factor out, which might seem crazy to you, 1 over 118. Now, what would that give me? 7, 40, 3. Yeah, they're nasty. No doubt about it. But the fraction was nastier. 14 minus, well, 2 times 19 would be 38, right? And then what do you get? 6. Again, you would need to know basic grade school arithmetic to do what I'm doing, by the way. Minus 9. I'm not saying you can't make mistakes. I make mistakes all the time. 16 and 13. And it's going to be multiplied by the matrix 8, 2, minus 6. And yes, computers can do arithmetic too. I know that. So what I'm going to do over here, I'm going to do the multiplication. I'm going to put it on I'm doing this. And they're nasty. There's no doubt about it. All right. But really what I have in the end of it, I had this really simple matrix, by the way. And I'm going to write this arithmetic because it's much nastier than the other ones. And 7 times 8 is 56. And 40 times 2 is 80. And 3 times minus 6 is minus 18. And someone said, I need a calculator for that. I don't think so. But maybe you do. 56, and this would be 62, right? Right? So let's say 50 and 60 is 110. Oh, 118. Some people say, why do numbers work out so nicely? We write problems so they work out nicely. Let's do the next one. What's 14 times 8? That's 80 and 32. That's 112. I always say if things are not working out, you're probably doing something wrong. Let's see, minus 38 times 2. Let's see, that's minus 76, right? And then 6 times minus 6 is minus 36. Well, let's do this. 112. Let's see, that's minus, oh, look at that, minus 112. That's 0. Really nice. All right, let's do the next one. Let's see, you get, and again, it's bigger numbers, and I have to do it. Minus 72 plus 32. Let's see, 6 times minus 13. That's going to be 60 and 18 minus 78, right? Did I do something wrong here? Minus 72, 32, 60 minus 78. Wow, that's going to be a lot of work, isn't it? Let's take a look at it. Minus 40, minus 150, plus 32. Wow, minus 118. What does this produce? 1, 0, minus 1. All right, now I'm going to write down what that means to me. It means x is 1, y is 0, and z is minus 1. Now, by the way, I like the numbers are easy. I'm not saying I'm right, by the way. I'm just saying I like those numbers. They're really easy. I want to go back to the original system now. I'll pull it over. Just give me 1 second to do so. Whoops, sorry about that. And I'm going to see if this makes any sense. We'll check with the key later. And let's write this down. So x is 1, what would I get? 5, 2, 1. If y is 0, I don't get any y's. I got the z's though. What does it give me? Plus 3, and that would be minus 7. This is 2, this is minus 6, and this is 8. Is that what they said it was going to be? They sure did. 8, 2 minus 6. Everything's working out. So let's go back to the key and let's see if the key's saying that. All right. X is 1, Y is 0, and Z is minus 1. All right, let's go to the next page. I think we're done with that. Yep, and problem number 8. Number 8 says find the inverse if possible. Now, by the way, that's a big thing saying it's possible. It may not be possible, but again, we're not giving you things you can't do. So what I'm going to suggest, what we talked about in class, is I'm going to use an augmented matrix and try to do it in one shot. All right, so I'll put this over here. All right, so 1, 3. I'm trying to get into reduced row echelon form. I'm trying to do everything at one time now. So what we're going to try to do is transform this left side so it's in that reduced row echelon form. And what I mean by that is going to look like this over here. And then what comes over here is actually what's going to be called the inverse. All right, let's see if we can do it. And I'm going to put a little thing over here and see if I can do that. And what I'm going to do is I'm going to say, and I'll write it down for you. So I'm going to say, minus 4 row 1 plus row 2 and give it to row 2. Again, I have a little more experience with this. And I'm not saying it's a great amount of experience, but a little bit more experience. And I'm going to say, I really do anything to row 1. So I'll write this down. That's going to be 1, 3, 1, 0. But what am I doing? I'm doing minus 4 times row 1 and adding it to row 2. So this entry would be 0. All right. Now, minus 4 times 3 is minus 12 plus 13. That's 1. Okay. Now, minus 4 times 1 plus 0 is minus 4. And let's see, I'm sorry, did I say that right? Yeah, minus 4 times 1 is minus 4 plus 0 is minus 4. And then what do I get? Minus 4 times 0 is 0 plus 1 is 1. Now, do I make mistakes all the time? And we'll check this later. There's many ways to check it. You can just look at the answer key if you like to, if you're exhausted. Now, I got to get another 0. And I'm going to do that by, well, let's take a look at it. I'm going to do minus 3 row 2 plus row 1, and I'm going to give it to row 1. All right. Let's see if I can do that. All right, I'm write that for you. Let's see. Minus 3 times 0 is 0, plus 1 is 1. That was easy. Minus 3 times 1 is minus 3. Minus 3 plus 3 is 0. Well, I got the bingo now. I got this identity matrix on the left side now. Let's do it on the right side. You would get 12 plus 1, which is 13. And then you would get, let's see, minus 3 plus 0 is minus 3, right? So I'm going to say the inverse. I'll write this down now. The inverse, let me make sure I copied the right matrix. 1, 3, 4, 13. The inverse is 13 minus 3 minus 4, 1. Now, but I don't want to belabor this too much, but that's what they asked me to do. My question is, I wonder if I'm right. There's an easy way to do it, by the way. I want to point out, I'm going to write this over here. Just going to check it. 1, 3, 4, 13. And what do you get over here? 13 minus 3 minus 4, 1. And I make mistakes. Even simple problems like this, I make mistakes. What would that give you? Well, it'll be 13 minus 12. That's 1. That's a bingo. And then what do you get? We get minus 3 plus 3. That's 0. That's great news. This is going to be 4 times 13 minus 4 times 13. That's 0. That's pretty easy. And let's see, 4 times minus 3 is minus 12 plus 13 is 1. Bingo. This is definitely the inverse. I would say look at the key, though, and make sure the key is saying that. And it is saying that. It's saying 13 minus 3 minus 4, 1. All right. Now, granted, I know this is more difficult, and a lot of students struggle with this. They really struggle with it. All right. And I think what they're struggling with is not the one step, it's taking more than one step. I gotta be honest with you. No one enjoys taking an inverse. There's formulas for it. Machines can do it. but I got to go through it with you. I want to put out the first thing you're going to be doing is putting down that augmented matrix. All right. And then you're going to try and transform. So I want you to simply, I want to say this is sort of typed up for you. All right. So I'm going to tell you again, the first step, the very first step is this step right over here. Your goal, though, which may be very difficult to do, is to get the left of the bar to become the identity matrix. This is your goal. If you can do this, this would be the inverse. The inverse of who? The inverse of this guy over here. Well, let's go through it. Now, someone says, how would you go through that? There's many ways to do it. I'm going to write it down for you, though, and I'm going to talk about what the steps are involved. I'm going to be using my eraser, which can be incredibly dangerous to do. And what I mean by that, when you use an eraser, you lose a lot of information and you can't trace it back. If you do use an eraser, you have to start over again, which can be very, very difficult. But I'm going to write down what I'd like to do. Now, certainly one day I may do one thing, another day I may do another thing. So what I'm going to do over here is I'm looking at it and I'm just going to say, maybe -1 times row 2, add it to row 3, whoops, add it to row 3 and give it to row 3. Now, I believe I can do it. And so what would I get? And I just really care. I'm going to write down on the side. I'm going to erase, though. I would get 0. I would get 1. I would get 1. Again, I'm doing -1 times row 2. Okay. I would get 0. I would get -1. I would get 1. I'm going to put my eraser out now. I'll write that down for you. Right, 0, 1, 1, 0, -1, 1. And I'm gonna start to erase here. And again, I really have to tell you this, erasing is really dangerous because you lose all information about what you've done. And it's very hard to undo something when you erase your tracks. It's like walking into the wilderness and not having a way out. And that can be kind of scary. So I'm going to look at this again. What I'm going to do now is something different. And I'm going to do, let's see, minus, whoops, I'll do it in red. I'm sorry. -1 times row 3. I'm going to add it to row 1 and give it to row 1. Let's see what I get there. I'm going to write down for you. So let's see, you get 1, none, none. Wow, that was easy. So again, minus, this is row 3. All right, get my eraser. It doesn't look right. Okay, so -1 row 3, so that'd be 1, none, none. What do I get over there? 1, 1, -1. I'm going to get my eraser. I'm going to erase. And what do you get there? You get 1, whoops, go back to black. 1, 0, 0, 1, 1, -1. I'm going to erase. And again, I can't say this enough times. Erasing is very bad news, but sometimes you have no choice. All right. Now, I got more work to do. I'm getting close, though, aren't I? And I'm wondering what could I do now? And I'm gonna look at it and see what can I do. Some say, why you do that, not this? Well, we want you to try too. We want you to do things. So I'm gonna write this down for you. -3, row 1 plus row 2, and I want to give it to row 2. Let me see what I get there. I would get 0, 5, 4, minus 3, minus 2, and 3. All right, get my eraser out. Let me make sure I did that right though. Minus 3 would be 0, 5, 4, minus 3, minus 3 plus 1, minus 2, and 3. Yeah, I did a good job. By the way, it's a famous last word. I did a good job. When you find out you didn't get the right answer, say, Jeff must have made a mistake somewhere. Let's write this down for you. And what do you get? 0, 5, 4, minus 3, minus 2, 3. So I got it. 0, 5, 4, minus 3, minus 2, 3. I did a good job. I'm going to erase now. Yeah, I'm going to say it's a really bad idea to erase. All right, let's keep going. And let's see. I guess what I could do, I'll write this down for you. Oh boy, minus, no, I'll do it in red. Minus 4, row 3, add it to row 2, and give it to row 2. All right, see if I can do that. We get 0. Let's see, minus 4 plus 5 is 1. Minus 4 plus 4 is none. Then I get minus 3. That would be 4 plus a minus 2 is 2. And then you get minus 4 plus 3 is 1. And I'm going to write that down for you. Eraser. And that's going to row 2, right? All right, let's write it down. What'd you get? 0, 1, 0. We're getting close though. Minus 3, 2. And I think I made a mistake in that last thing. It's 3, 2. I think I made a mistake there. It's minus 1. We'll check it though. All right, what am I going to do now? I guess I get another 0, right? Erase. And we're getting close. And what I'm going to do over here, I guess I would do minus 1 times row 2, add it to row 3, and give it to row 3. Well, I think I can do this one now pretty quickly. So what would I get? I'll write it down for you. 0, 0, 1, 3, minus 3, and 1 plus 1 is 2. All right. So I'm going to get my eraser out. I'll erase this down now. What do you get there? 0. Whoops, sorry about that. 0, 0, 1, 3, minus 3, 2. Let's see if I got the right answer. 1, 1, minus 1, minus 3, 2, minus 1, 3, minus 3, and 2. Good job. Okay, so what I'm going to do now is I just want to go to the computer. You realize how long that took me, how kind of confused I was at some point. A lot of arithmetic was going on. So I'm going to go do another share with you. And I would recommend you learn how to use a computer. And just give me 1 second. I got to do a new share. And what I'm going to do is I'll just do this. And I kind of remember. So I'm going to say A is a matrix. This is why we take notes, by the way. If you can't remember me doing this, you probably haven't been taking notes. What's the first row? 1, 1, 1. By the way, I am looking at my notes to do that. I don't remember the matrix at all. And then the second row is 3, 5, 4. And then the next row was 3, 6, 5. And what I want to do, A inverse. And let's see if the computer can do the same thing. Yeah, I hope I didn't copy anything wrong. What do they say? 1, 1, minus 1, minus 3, 2, minus 1. Yeah, I did pretty good. 3, minus 3, 2. Good job. We got it. All right, let me go back to the screen share of the whiteboard. All right, so we did all right with that. We did it by hand. So I want to read it to you. It says, this method, along with using your calculator, which could be Sage, by the way, will be discussed in class. We just did discuss it. All right. I know it's difficult, and I will try to go easy on you with regard to finding inverses. However, you should learn how to use a computer. But before you do that, you should struggle with hand arithmetic. All right. You really should. All right, go to the next thing. I think there is no next thing here, but I'll just see if there is. Nope, that's it. So we're done with it. All right. I know it's tough. All right. Good luck to you.